Let's continue to answer the question, who does the public transit system serve? Recall that we broke up this bigger question into 3 sub-questions. Where are the transit stops and lines? What geographic area is served by the transit system? And what are the demographic characteristics of the people served? In the last video, we answered the first sub-question by using GTFS public transit data to map the locations of transit stops and lines. In this video, we'll focus on the second sub-question. What geographic area is served by the transit system? We'll make use of the transit stops feature class we created in the previous video and the service area tool in the network analyst extension to map the area served by the transit system. First, let's start with some principles and best practices. The map here shows the transit stops and lines in Ann Arbor, Michigan. I'm just using Ann Arbor for this particular discussion instead of the Cincinnati tutorial data because it's a smaller town than Cincinnati and it's easier to see the details. We'll get back to Cincinnati for the demo later. Now we want to use the data to create a coverage map that looks something like this, that shows which areas of town are served by the public transit system. This map shows the area within a quarter mile of a transit stop. Typically, at least in the US, people consider a quarter-mile walk distance as a reasonable distance for people to travel to transit. A quarter mile is about 0.4 kilometers. So when mapping your transit system coverage, the first thing you may be tempted to do is to create a quarter-mile buffer around your transit lines. Do not do this. For the most part, unless you have a flag-down system, people can only get on and off your buses or subways or whatever at stops. People can't just jump on or off the bus or train as it rolls along. They have to use the designated stops. If you buffer around the lines, you'll drastically overestimate the area served. Thus, the lines, or shapes, are not valuable in assessing the area served by your transit system. Okay, hopefully I've convinced you that we need to look at the stops and not the lines. Let's take a look at an individual transit stop. The next thing you might be tempted to do is to create a quarter-mile circular buffer around the transit stops. Do not do this either. Although this is a little better than line buffers, it's still not great. After all, people usually can't walk in a straight line in every direction from the transit stop. They're constrained, for the most part, to walk along the streets or sidewalks. If you have to zigzag through a warren of streets, your quarter mile will be expended before you reach a quarter mile as the crow flies. You might also run into geographic or man-made features in the way, like a river or a highway with no pedestrian crossing. So circular buffers around stops can also drastically overestimate the area within a short walk of each stop, and in turn, the area served by the transit system as a whole. So what's the solution? What should you do? Use a service area. A service area is a polygon representing the area reachable from a given point within some time or distance limit, when subject to the constraints of an underlying road network. You may have also heard a service area referred to as an isochrone. I'll just call it a service area because that's the terminology we use in ArcGIS Pro. You can see in the image here the big contrast between the service area polygon and the circular buffer. The service area is much more accurate. In particular, you can see that this area on the bottom left, where there's a cul-de-sac and some streets from a different neighborhood, are included in the circular buffer but excluded from the service area, because people in that neighborhood would have to walk a long circuitous path all the way around to get back to the transit stop. You can create service areas in ArcGIS using the Network Analyst extension, and I'm going to show you how to do that in a bit. Let me finish up my discussion of transit system coverage first. Let's go back to the transit line we were looking at and compare the line buffer with the map of service areas surrounding each stop. You can see that there's a huge difference. If we create a quarter-mile service area around all the stops in the system, we get something like this. We have now successfully calculated the area served by the transit system. Now, as promised, let's talk about how to create a service area and what it really is. To do that, I need to give you a bit of an introduction to the Network Analyst extension. The ArcGIS Network Analyst extension is the part of the software that's for solving transportation analysis problems. It has tools for assessing the coverage of different facilities, for optimizing things like site location and fleets of vehicles, and for point-to-point routing, such as how do I get from point A to point B? What's the closest facility? And for solving origin-destination cost matrices. Network Analyst has several solvers, as we call them, and Service Area is one of them. Underlying all Network Analyst workflows is a network dataset. This is a dataset that includes street features and also attributes describing travel times and distances, restrictions for travel, etc. When you perform an analysis, you have to choose which network you want to use to perform the network analysis calculation. Where do you get a network dataset? You can purchase StreetMap Premium, which includes a high-quality network dataset for your selected country or region. You can also purchase the StreetMap Premium Custom Roads product, which includes the StreetMap Premium data as well as the flexibility to add your own roads or attributes to the dataset. The Custom Roads option might be useful to you later if you want to add transit schedule data to your network dataset, but we'll talk about that in a later video. You can build your own network dataset using your organization's data. There's some help available if you're a local government trying to build a network dataset from your street center lines. You can also use other data sources like Tiger and OpenStreetMap, although often the data quality isn't great and it will require a lot of work. Also, you might not need your own network dataset at all. You can use the ArcGIS Online services to perform your network analysis calculations. Those services use the same data as StreetMap Premium, but you don't have to own the data. You just pay service credits and let the servers do the work for you using the data that lives there. If you just want to map your transit system coverage, this is sufficient. However, if you want to add your transit schedules into your network, as we'll discuss in a later video, you won't be able to do that with ArcGIS Online. Service area is one of the network analyst solvers, and the service area polygon represents the area reachable from a given point within some time or distance limit when subject to the constraints of an underlying road network. The service area workflow in ArcGIS Pro involves 4 main steps. I'll give you an overview here, and then I'll show you the steps in a demo. First, you create the service area layer. You have to choose the network dataset or service you want the service area to reference, and then create the layer. The service area layer is a group layer that includes the analysis input and output data, as well as the settings used in the service area analysis. You can configure the settings using the service area ribbon. Next, you need to add your input data. For service area, this is called facilities, and it represents the locations around which you want to calculate the service area polygons. For our current analysis, we'll use the public transit stops as the facilities. Next, you solve the analysis. This is when the software actually does the calculation and produces results. And then finally, you work with the results to do whatever it is you need to do with them. There's a link on the slide to a tutorial showing you how to do this process in ArcGIS Pro. Now I'll show you the service area workflow in a demo. I'll create service areas around the public transit stops to map the area served by the transit system. Here we are in ArcGIS Pro, and you can see that in my map I have my data of Cincinnati stops that we created earlier using the GTFS data. I also have a network data set that I got from StreetMap Premium that covers this area. So now I want to create a service area layer and add the transit stops to the service area layer as facilities, solve the layer, and then examine the results. So I'll go to the Analysis tab, and on the Network Analysis dropdown, I get an option of which network analysis type I want to do. So I'll pick Service Area, but first, take a look here. This is showing me that the current network data source that the new service area will reference is my StreetMap Premium dataset that I just mentioned. But I could choose a different data source if I wanted to. I could choose a different network dataset, or I could choose an ArcGIS Online or ArcGIS Enterprise routing service. But for now, I'll leave it with my StreetMap Premium data, and I'll click Service Area, and this will create my service area layer. So as I mentioned earlier, a service area layer is basically a container that includes the input and output data of the service area, as well as the settings that are used to run the analysis. All right, my service area layer has been created. You can see it here in the table of contents. It's a group layer. The facilities are the inputs that we care about, and the polygons are the outputs that we care about. Point line and polygon barriers are just an optional input if you had some kind of barrier that you needed to add into your analysis, like the location of a flood or a closed road, but we don't care about that for the moment. Lines is another output that isn't particularly useful for us at the moment, so I'll just not talk about that. So you'll notice up here we have a surface area ribbon, and there are several options here for changing the way that the surface area runs. This thing that says mode, this is the travel mode. And my StreetMap Premium data comes with several options of travel modes. And I'm going to change this to walking distance because what I want to calculate is the distance around each input location. Now you'll notice that the units here are in kilometers. That's fine. I was going to do a quarter-mile buffer, but since my units are in kilometers, I'll just do a 0.4 kilometer distance, which is just about the same as a quarter mile. Now there's a couple of other options that I should show you. For output geometry, I'm going to choose high precision, which is generally a good idea when you're doing pedestrian scale analysis. This gives you the greatest level of detail. It does make it solve a little bit slower, but I think it's still important for you to get the highest precision of polygon when you're dealing with pedestrians and walking. Now there's an option here for how you should handle the output surface area polygons from multiple facilities. You can choose to generate an individual polygon around each facility using the overlap option, or you could dissolve them so that you just get one huge polygon where all of the different surface areas are kind of combined together. This is a reasonable option if you just want to visualize the area that's reachable, but I'm going to leave it with the overlap option now for reasons that we'll discuss later. Basically, when I'm doing a demographic analysis of who has access to each transit stop, I need to have an individual polygon for each stop. Okay, so the next thing I need to do is import the surface area facilities. So I'm going to import the public transit stops to use as facilities in the surface area layer. Now you can see all these yellow dots here. That's because the transit stops have been loaded as facilities into the surface area layer. Now I'm ready to solve the surface area analysis. To do that, I just click the Run button on the ribbon, and it will solve. Now this is going to take a little while because it's solving quite a large number of surface areas. I'll go ahead and speed up the video so that you don't have to sit through this. All right, the solve is finished. And let me just turn off some of this extra data so that it's easier to see the results. You can see now that we've got little polygons showing the area that's within 0.4 kilometers of each of the public transit stops. So if I zoom in, you can see it in more detail. You can see there's quite a bit of overlap among several of these surface area polygons, which is to be expected. Here's the stops, you can get some better idea. That concludes our demo. We successfully created a polygon layer showing the area reachable within a quarter mile, or 0.4 kilometers, of all the transit stops in our system. Before we move on, I want to draw your attention to an important distinction. With Network Analyst, it's possible to model traveling to and from public transit stops, and it's also possible to model traveling by public transit in order to reach destinations. So far, we haven't talked about this second point, but we'll get there later. Right now, we're talking about ordinary road networks that model pedestrians walking to and from transit stops. We're just trying to assess how easy it is for someone to get to the transit system, not how easy it is for them to get to work by riding transit. For this situation we're modeling right now, the transit stops are not part of your network dataset. They're actually the input of your analysis, the surface area facilities. For the other case, the public transit stops will be included as a part of the underlying network dataset so that we can model travelers using the stops to get where they're going.